Hi guys, good morning. Can you hear me?
Good morning, Nageswar Rao.
Yeah, thank you. So we'll start session. So yesterday class, 1 second, Java documents. So all these basics completed in yesterday's class. Yes, interpreter compiler, the differences completed. Okay. So main difference exe file. Compiler generates exe file. Interpreter based language don't have exe file. Next, Java depends on both compiler as well as interpreter. Java depends on both compiler as well as interpreter. Okay. So Java errors checking by the compiler, runtime by the interpreter. Java runtime by the interpreter. So involving both. Yes, Java source code to byte code to binary code. So you get byte code in the system. So why byte code? So this is to make the Java is independent platform. Yes, today topic. Now we'll discuss about how Java made us independent platform. Let us see now there. Okay. Yes. Source code to byte code by the compiler, byte code to binary code by the interpreter. So there are two things involving. So yesterday I showed practically. So first the comparison Java compiler, Java to run the program. So Java C, Java compiler, Java interpreter. Okay, compiler and interpreter both involving. Okay, yes, in Java there is no exe file concept. We can't create exe file. Everything is dot class. Okay, yes. So there is no concept of exe file in Java. Okay, no exe file. We can't create exe file. In Java, everything is a dot class file. Okay, dot class is not exe file. So dot class is not an exe file. Ex is different, dot class is different. Okay, now let's see features of Java. So this topic. Yes, 1 second. Yes, yes, features of Java. So independent platform. So how Java made us independent platform? So this topic will discuss today now. Yes. See how Java, yes, Java made us, yes, independent platform. How Java made us independent platform? So this is question. Let us see. Yes, to understand this, first of all, let us see about exe file concepts. Yes, about exe file, about exe file, about exe file, about exe. First of all, about exe file. So once you understand that exe file, next we'll see about dot class file. Then we'll discuss about how Java made us independent platform. So about exe file. See here some question for you guys. Some question. Yes, exe file prepared. Exe file prepared. Exe file prepared. 1 second. Change the font size. Suppose exe file prepared on Windows OS. On Windows OS. Exe file prepared on Windows OS. Yes, exe file prepared on Windows OS. Exe file prepared on Windows OS. Can I run? Can I run on Linux OS? Is a question. Yes, question. Of course, I'll explain. Very simple question. Of course, I'll explain. Yes, exe file prepared on Windows OS. Can I run on Linux OS? Yes or no answer. Yes, exe file prepared on Linux OS. Sorry, exe file prepared on Windows OS. Can I run on Linux OS? That's a question. Simple question. Simple question. Yes, simple question. Exe file prepared on Windows OS. Can I run on Linux OS? Very simple question. Very simple question. Yes. Okay, fine. Answer is no. Yes. For this answer is no. Yes, for this answer is no. Reason. What is the reason? What's the reason? Yes, exe file is a OS dependent. OS dependent. Yes, simple reason. Exe file is OS dependent. That's like a fine. Now question is here, why exe file is OS dependent? Yes, exe file is OS dependent. Yes, if exe file prepared on Windows OS, it will run on only Windows OS. Yes, it won't work with other operations. Suppose exe file prepared on Linux OS, only a Linux OS. If it is on Unix OS, only Unix OS here. Exe file is a OS dependent. Exe file is a OS dependent. Exe file is a OS dependent. It's a OS dependent. Okay, exe file is a OS dependent. Okay. Yes, why exe file is OS dependent? Yes. Anyone idea? Exe file is OS dependent. Why? Why exe file is OS dependent? Yes. So for this one here, you must have exe file knowledge. So yes, exe file contains what? Okay. Exe file contains what? What does it contain here? Exe file. What does it contain here? Okay. So exe file. What does it contain? Exe file. Yes. Yes. What does it contain? Let us see about this. Okay. Suppose, for example, exe file prepared on Linux base. Linux base. Okay. For example, here, yes, C program exe. For example, C program exe file. C program exe file prepared on Linux base. C program exe file prepared on Linux base. Linux base. Then it contains. It contains. It contains. Yes, let me show practically. Yes, let us go to Linux base. So demo login. Yes, Linux. Login at Linux base. So yesterday, yes, C program. Yes, expands Linux base. C ls cd mnrf. You guys don't think about Linux base. I'm using some ls commands, cd commands. You don't think about it. Yes. See, Java you can develop on Linux also. See, Java, Eclipse. It's in Linux Eclipse installed here. Okay. Yes, I'll explain here also. Linux also how to develop Java applications we'll discuss. Linux also I'll explain. So how to set up Java in Linux base. Not only Windows base or Linux platform also I'll explain. Don't worry. Okay. Yes, now here 1 second. Remove. Yes, remove TLS. Yes, test.c test program, right? Test.c. Cedit, zedit, cedit, test.c. testers, gd test.c. See, so this is program, right? Say hash include std IO data. So main function int a equal to and b equal to. So this is our C program. C program, right? C program. This is C program. Okay, right? Next, std IO data set is a header file. See, this header file also developed in C language. Yes, C language header files developed in C language only here. This header file also is a C program. Okay. For this header file, already binary code is available. Already its binary code is available. Already prepared binary code is available. std IO data header file, binary file already available. Okay, now your C, these are your C program. Your C program. Okay, now compiling. So when you compiling your C program, yes, gcc-c tester, just a compiling. Yes, compiled ls. test2.to file generated, right? Yes, here .to file. .to means object file. So this object file contains binary code for your C program. Means yes, only this part, wide main from this to top to bottom, binary code of C program. So this header file is having its own binary code. This header file already prepared file, already in binary format available. Now for our program binary code is the test.to file. Okay, so test.to file contains binary code for our C program. Okay, binary code for C program. Test.to file contains binary code of C program. Okay, now gcc -o. Yes, now project is exe name. Project is exe name. That result exe. So tested.o. Okay, now exe file created. Yes, project exe file. Now what happens at the time of creation of exe file? What happens here? GCC, C language compiler, taking test.to, that means binary code for our C program. Test.to contains binary code for C program. So it's taking, yes. So compiler taking binary code for the C program plus binary code for std IO data header file means C library. Binary code for C library plus binary code for OS library. Yes, in OS there is a library. In OS there is a library. See, starting we discussed. So at the beginning about OS we have discussed, right? See this. In OS there is a library. Every OS has its own library to communicate with hardware components. Okay. Here there is a library, right? There is a library. OS library. There's some input output library to communicate with hardware components. A library to communicate with the hardware. So purpose of library is to communicate with the hardware, right? Okay, hardware. Okay. So every OS has its own libraries. This point, every OS has its own libraries to communicate between application software hardware components. So this library. So this library links to that project exe file. Okay. See, at the time of creation of exe file, what happens here? Now C language that compiler taking binary code for our program, test.to, binary code for our program, binary code for your program, plus binary code for std IO data header file, means C library, binary code for C library, and binary code of OS library. By linking all these three, finally generating exe file. exe file. So that exe file contains what? Okay, exe file. A C program exe file prepared Linux based, then it contains binary codes. Then it contains binary codes for a C program. Yes, binary code of C program, binary code of C program, binary code of C program. Yes, plus yes, binary codes. Yes, binary code of C library, 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 plus yes, binary codes of yes, binary code of OS library, OS library, OS library. Okay, so finally that exe file contains yes, C program binary codes, yes, C library binary codes, and OS library binary codes. By linking all of this in generating a 1 second, let me have some water. Yes, by linking all of this in generates exe file. By linking all of this in generating exe file. So by linking all of this in generating exe file, right? So finally that exe file contains what? Project exe file, binary code for your C program, binary code for C library plus binary code for OS library. So OS library also part of exe file. So OS library linked with project exe, right? So project exe, no, yes running. So once you run this here, inside of project exe file, there is a OS library. Using OS library, then communicating with the hardware components. So output getting through the OS library. Okay, see, at the beginning we have discussed about one point here. See, every program links with OS library before going to start execution. Yes, every program has to link. Every program has to link. These programs, C program or C++, Java, Hadoop. So these programs, every program has to link with OS library. So every program has to link with OS library to run it here. Otherwise cannot. It has to link compulsory. Every program has to link. Every program, these all the programs have to link. These programs has to link with OS library to communicate with hardware components. Compulsory here. Linking. Now in case of exe file, at the time of creation of exe file itself, linking OS library. This is called a static linking. So exe file creation, it's a static linking. So statically linking at the time of creation of exe file itself. At the time of creation of exe file itself, that OS library links to project exe is a statically linking. It's a statically linking. Is a statically linking. Statically linking. Okay, right? So you get that exe file. So exe file. So for example, C program exe file prepared Linux base. Then it contains binary code of C program plus binary code for C library, binary code for OS library. It contains binary code of C program, binary code of C library, binary code of OS library. Suppose one more example. Let us see one more example. Another example here. C program exe file prepared on Windows OS. Windows OS. Windows OS. Then it contains binary code of C program. Yes, binary code of C library. Yes, binary code for yes. 1 second. Here Linux based library. So Linux based library. Here it's Windows OS library. Windows OS library. Okay. See Windows. If it is Windows OS, let us see. Now here creating exe file here. Windows OS. Turbo C. See yesterday's program, same program. Math.cpp or C program, both are same. C compiling. So once C compile here, now this one generates that math.o file generates. Alt C compilation. Just a compile means this will generate only object file. Object file generated. After generating object file, yes, object file generated. 1 second. Backend. Let us go backend of Turbo C. C drive. Yes, here Turbo C install bin directory. Yes, math. So math. See, here this is application. This removing. This is also removing. See math.c. These are file. So this is file. This is file here. Okay. Yes. 1 second. Saved. 1 second. Saved. Yes. Math.cp file. See 954. Yes, see October 22nd, 2021. Just now 9 timestamp. See the timestamp. Just now it's a modified. Is a time of date modified. Time of modification. Just now modified. So this is our program. Okay. Just here I'm compiling Alt C for compilation compiled. See, once you compile, see this object file created. See that object file created. Once you compile object file created, okay. So object file created. After this, now run it. So when you try to run it here, what happens? Some exe file creates, right? Yesterday I showed first exe file creates. Run. Yes, see that. Yes, back and exe file created. This exe file created. It's exe file. See properties. Dot exe file. So dot exe file created. So at the time of creation of exe file, you have this object file, math.o, that object file, obj file. Yes, here I think extension obj dot obj. Linux dot y, here it's a dot obj. That object file linking with this OS library, Windows OS library. Okay, so this object file and C language header file binary codes linking and next OS library, Windows OS library linking, finally generating exe. This is the exe file. It's exe file generated. After generating exe file, that is executed. Okay, yes, enter first number, support 10. Yes, second number 20. So addition, subtraction 1. Same here, same. Okay, so C program exe file prepared in Windows OS, then it contains, yes, binary code for C program, binary code for C library, binary code for Windows OS library. That's it. Suppose if it is C++ program, for example, let us take C++ example here. C++ example. Suppose C++ program exe file, yes, prepared on Windows OS, then it contains binary code for C++ program, binary code for C++ program, binary code for C++ program. Yes, next binary code for C++ library. Yes, C++ library, something like iOS team data set file. In C++, this iOS team data, it's like that. Okay, C++ library. Yes, plus binary code for Windows OS library. That's it. So OS library is a part of exe file. So at the time of creating exe file itself, OS library becomes part of exe file. At the time of creating exe file itself, OS library links to exe file. Okay, 1 second. Yes. So at the time of creation of exe file, see at the time of creation of exe file itself, OS library becomes part of exe file. So OS library linked, all are linked with exe file, means that is called static linking. At the time of creation of exe file itself, that way, yes, at the time of creation of exe file itself, yes, OS library linking to exe file. So exe file is a part of, sorry, OS library is a part of exe file. All are linked, right? Okay, yes, all are linked. Now, how that exe file is working? Let us see. So, for example, here, for example, test.exe file, test.exe file prepared. Yes, test.exe file prepared on Windows OS. Test.exe file prepared on Windows OS. Okay. Yes, test.exe file prepared on Windows OS. Then it contains Windows OS library. Okay, test.exe file contains Windows OS library. Now, this test.exe file placing on different platforms. Let us see on different platforms how it's working on different platforms with different operations. How it's working. See, sorry, how it's working. Let us see. See, hardware, 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 hardware. See, on top of hardware, this OS. Yes, Windows OS. Yes, Windows. What's happening? Yes, Windows OS. Yes, with the Win library. Windows library, right? So hardware, on top of hardware, this is Windows OS is running, right? Yes. Not test.exe file. Yes. Placing on Windows OS. So this test.exe placing on Windows OS. Test.exe file. Not test.exe. Right? Yes. Now what happens here? So test.exe file, when you try to run on Windows OS, okay, test.exe. So this is test.exe file, right? Test.exe file. Okay. So test.exe file. Test.exe file. So when you're running this one, just see this, when run this, some output getting like this, right? Okay. Run. Yes. Okay, done. So test.exe file. When you try to run this test.exe file, yes, it makes a call to Windows library. The test.exe file makes a call to Windows library. Yes, that Windows library. Yes, here it's available. Using that library, it communicates with hardware components. That over. Okay, so test.exe file already linked with Windows library. Okay, test.exe file. Okay, then it contains Windows library, Windows OS library, Windows OS library. Now at runtime, it makes a call to Windows library to communicate with hardware components. Yes, test.exe file, it will try to call Windows library to communicate with hardware components. So it will try to call Windows library. Yes, it's available. So simply Windows library invoking. Yes, with that Windows library communicates with hardware components. Done. Suppose same test.exe file, let us place on, let us see on another platform what happens here. Same exe file placing on another platform, what happens? Let us see. Next, another platform. Suppose let us take Linux. Linux platform with the Linux library. Linux platform with Linux library. Yes, how this is working. Let us see how it's working, how this is working here. So how it's working here, how it's working. Let us see about this. Now, same test.exe file. When you try to run a Linux base, what happens? This test.exe file placing a Linux base. After moving at Linux base, running. So when you try to run it here, test.exe file. Yes. This is exe file is already linked with Windows OS library. Windows library is a part of exe file, already linked. So when you try to run it here, yes, it will try to call Windows library. This test.exe file, it will try to call Windows library. It will try to call Windows library, but it is not available. Library is different here. It's Linux library. Yes, here Windows library is not available. That library is not matching. Simply fails. Simply fails. It won't run here. That's the reason. So exe file is a OS dependent. Reason it contains OS library. Okay. So why exe file is OS dependent? Reason it contains OS. Reason it contains OS library. Now let us take another platform. Suppose. So for example, one more platform. Let us take another platform. One second. Another platform. Suppose Linux platform. Linux platform. Okay. Same test.exe file place. Sorry, Unix platform. Linux over already. Unix platform. So next Unix platform. Let us take Unix platform. Unix platform. Okay. Not when you try to run test.exe file in Unix platform here. Yes, it will try to call Windows library, but here is not available. That library is not matching. Simply fails. Simply fails. That exe file fails. So exe file is a OS dependent reason. See here. So what is first question? Yes, about exe file. So exe file prepared on Windows OS. Can I run on Linux base? No. No. Yes, reason exe file is a OS dependent. So why exe file is OS dependent? So why exe file is OS dependent? Now what is the answer for this? What's the answer for this? Yes, it contains OS library. It contains OS library. It contains OS library. So this is the reason. It contains OS library. It linked with OS library. So it contains OS library. Since exe file contains OS library, it's a OS dependent. Okay. Yes. Since see since yes since yes exe file linked with OS library. So OS library, yes. Since exe file linked with OS library, yes, it is a OS dependent. It's a OS dependent. OS dependent. OS dependent. Okay. So OS dependent. Okay. The exe file is linked with OS library, OS dependent. Okay. 1 second. See, I'll show that also. The contents also we can see. Actually, this is embedded C concepts. Okay. See, at the beginning of my career, worked on embedded C. So that's the reason I'm able to explain all of these things. Okay. See, file projects. Project is exe name. See, it's exe name. So in Linux, this is a file command to check the type of file. So what is type of file? It's a executable file. It's a executable file prepared on 64-bit machine. Okay. Yes. Now see Linux library. See this. lib64 ld linux 8664 s4. This is what? This is OS library, the Linux OS library. Linux OS library is linked to this project exe file. That project exe file contains what? This is the Linux OS library. So so2. So this is, so so2.2 is a version, that library version. Okay. So this is Linux OS library. lib64, this contains what? All Linux libraries. Okay. So this Linux library is a part of this project exe. Yes, you understand? See the practical explanation. Okay. So you can, there's a library is there. That library linked to project exe. That project exe file contains Linux OS library. Okay. Actually, these are embedded C concepts here. Okay. So here, since exe file contains OS library, it's a part of, yes, sorry, yes, since exe file, yes, since exe file contains OS library, since exe file linked with OS library, it's a OS dependent. That's it. Okay. At the time of creation of exe file itself, at the time of creating exe file itself, that library links. Okay, it's called a statically linking. It's a statically linking. So this is about exe file. Fine. Yes. So here, this is a reason here. Why exe file is base dependent. Reason is this. Okay. Now let us come to Java. Now we can understand how Java made us independent platform. Okay. Yes. Let us come to Java. Yes, about Java. Okay. So Java program comparison. After comparison, generating dot class, right? Let us take same concept like Java, like yes, like C program. Same point I'm taking for Java also. Java. Yes, Java. Yes, C program exe file. In place of C, now it's a Java. Java program not exe, it's a dot class file. Java program dot class file. In place of exe is dot class file. So Java program dot class file prepared on Windows OS, prepared on Windows OS, prepared on Windows OS. Then it contains binary code of C program. But in Java, it's a byte code. It's a byte code. What is byte code? We'll discuss next. Yes, byte code. Yes, byte code. Byte code. Byte code of Java program. Byte code of Java program. So byte code of Java program plus, yes, byte code. Yes, byte code. Byte code of Java library. Like you see here, Java library. Java also library concept is out. Java library. Java library contains all the packages. Java library is a collection of packages and classes. Okay. Yes. So you can, yes, Java program dot class file prepared on Windows OS. Then it contains, see, yesterday command prompts. Yes, yesterday D:/D drive. Yes, in D drive there is a test directory is there. Test folder CLS. So dr, see test.java, right? So this is tested dot class. Tested dot class. So this tested dot class contains what? Tested dot, the tested dot class file. So contains, yes, prepared on Windows OS, tested dot class will prepared in Windows OS here. Then it contains byte code for Java program, byte code of Java program, byte code of Java library. Next, binary code of OS library. No, only this part. Okay, so here see this bytecode of Java program, bytecode of Java library. See, Java library also developed in Java. C library developed in C language. Java library developed in Java. That means, so dot class file. So dot class file. So dot class. So dot class file contains pure Java program. Dot class file contains pure Java. It's a pure Java program. Pure Java program. Pure Java program. Pure Java program in byte format. In byte format. In byte format. That's it. In byte format. So Java program, a dot class file contains pure Java program byte format. So dot class file don't have any OS library. So dot class file. So dot class file. Dot class file. Yes. Yes, does not. Dot class file does not contain. So does not contain any OS library. Any OS library. Any OS library. Okay. Any OS library. Okay. Yes. So dot class file. So don't have any OS library. Okay. See here. Dot class file. Dot class file. Yes. May be prepared. Dot class file may be prepared on anyways. Anyways. Okay. So dot class may be prepared on anyways here. Yes, you don't have. Yes, you don't have any OS library. You don't have OS library. Yes, that OS can be anyone. Dot class prepared on anyways. Okay. Okay. Dot class prepared on anyways here. Dot class may be prepared on anyways here. Yes, you don't have any OS library. You don't have. Yes, you don't have any OS library. Okay, so you don't have any OS library. So this is about dot class. So dot class file is a pure Java program. Dot class file is a pure Java program. Dot class file is a pure Java program. Okay, suppose let us take some tested dot class file. Tested dot class file. Okay, tested dot class file. So tested dot class file, right? Now this tested dot class file. Suppose prepared in this way. Yes, plain Java program. Yes, tested dot class file is a simply plain Java program. See that tested dot class is a plain Java program. Plain Java program, right? Plain Java program. Okay. Yes. Now, yes. Now this tested dot class file placing on different platforms. So let us take different platforms here. Like exe file here as dot class also. Let us take different platforms. How it's working on different platforms. Okay. So first about Windows platform. Okay. Tested dot class file. So tested dot class file. Tested dot class file. So tested dot class file. Okay. Placing an Windows platform. Placing an Windows platform. Okay. So this tested dot class file. So tested dot class file placing an Windows platform. After placing an Windows platform, yes, when you try to execute this one, what happens here? To execute this dot class file, this dot class file should be linked with Windows library, but it's not linked. It's a plain Java program. Yes, that file is not linked with any OS library. It's not linked. It's not linked. So the tested dot class file has to link. Okay, see here. See, every program has to link with OS library. Every program has to link with OS library to run it. To communicate with hardware components, every program has to link. Suppose if it is C language, what happens here? At the time of creation of exe file itself, linked, all are linked, static linking. So using that library, it will communicate. See, every program has to link with OS library. It's compulsory. Every program has to link with OS library, yes, to communicate with hardware components. See, every program has to link with OS library to communicate with hardware components. Okay, if it is C language or C++, exe file concept. At the time of creation of exe file itself, linking with exe file, OS level linked, so already linked, so direct execution. But when come to Java here, yes, this dot class, it's a plain Java program that don't have any OS level. Then how it can communicate with hardware? No, it cannot. It cannot communicate. It can't. Dot class file directly cannot communicate with hardware here. Okay, suppose if it is exe file, inside of exe file, already OS library is there. Using that, it communicates. Okay, that exe file. So that exe file contains Windows library. Using that library, communicates with the hardware. But when come to dot class file, so dot class file don't have any OS library. Then how it can communicate with hardware? So this dot class file has to communicate with hardware. How? Yes, someone has to link. Someone has to link this tested dot class to Windows library. Someone has to link tested dot class file to Windows library here. Okay, so between dot class file and Windows OS library, now one more layer comes. What is that layer? Anyone can guess it? So between these two, one more layer comes. Now one more layer comes. What is that layer? Yes, anyone can guess it? One more layer comes. Between dot class file, yes, Windows OS library, one more layer comes. So what is that layer? Yes, that layer is a JVM, Java Virtual Machine. Java Virtual Machine. That layer is a Java Virtual Machine. So one more layer comes. So Java Virtual Machine, Java Virtual Machine. Okay. Now what happens here? So first to tested dot class file. Yes, tested dot class file is not a prepared file. Simply just a Java program. So the dot class file making move to OS here. After moving on to OS here, now yes, as a part of Windows OS, this is JVM. Windows OS, this is JVM. This Windows JVM taking dot class file. Windows JVM taking tested dot class file, taking tested dot class file and links to Windows library. So what's happening at runtime? So JVM taking tested dot class file and links to Windows library. So it's a dynamically linking. It happens, link happens at runtime. Before running linking and execution, linking then execution, linking execution. Okay. So this is a dynamical linking. So it happens dynamical runtime linking. It's a runtime linking, dynamically linking. So dynamically, if it is C language, what happens here? exe file. In case of exe file, there is static link. In case of exe file, statically linking. At compile time itself, linking. That is called a static linking. In case of Java, what happens here? Runtime. It happens at runtime here. So JVM taking Windows JVM taking test dot class file links to Windows OS library means is a dynamically linking. So linking and running, just linking and running here. So it's a dynamical linking here, right? So JVM takes care of linking your dot class to Windows OS library. So once linked here, then communicates with hardware. So once linked here, yes, it can communicate with hardware components. That's it. So this is a case of Windows platform. Yes, next platform, Linux platform. Let us take next platform, Linux platform. 1 second. One second, just a minute. Yes, Linux platform. Linux platform क्या? So Linux base with Linux library. Now same test dot class file, moving on to Linux base. On Linux base, this is JVM. Yes, on Windows base, this is JVM. On Linux also is JVM. So Windows is having its own JVM. Linux is having its own JVM. Okay. Now here Linux JVM taking test.class for links to Linux OS library. So once linked here, it communicates with hardware. That's it done. So this link happens at runtime time. Depends on OS. Suppose dot class file, same dot class file, but running at different platforms. Same dot class file running at different platforms. So when dot class file is running on Windows OS, so JVM taking dot class file links to Windows OS library. Same dot class file when you're running a Linux base, JVM taking dot class file links to Linux base sites. Okay. Suppose same dot class file another base, another platform. Suppose Unix platform. Suppose if it is Unix platform. Okay. Unix platform. Yes, Unix library. Okay. Now same test dot classes. So this Unix JVM, this JVM taking test dot class file, yes, links to Unix library. So once linked communicated with the hardware components, right? That's it. Same dot class file running on different operations. See dot class file creating only once here. After creating dot class file, that dot class file, yes, when you're running on Windows OS here, So JVM links your dot class to Windows OS library. Same dot class file running on Linux base. Then Linux JVM taking dot class file links to Linux base library. Same dot class file running on Unix base. Unix base. Then Unix JVM taking dot class file links to Unix base library. So whenever OS changes here, that link changes. So whenever OS changes, link changes, right? So whenever OS changes here, so whenever yes, every time of changing OS, that link changes. Yes, if OS is Windows OS, links to Windows OS library. If OS is Linux OS, links to Linux library. Yes, if OS is Unix OS, links to Unix library. So JVM takes care of that. Same dot class file running on different platforms. This is nothing but independent platform. Same dot class file running on different applications. Need not to change any code as it is running here because of this JVM. So by end of this JVM. So JVM makes the Java as independent platform. JVM makes the Java as independent platform. So by end of this JVM is the reason here. So by end of this independent of how Java made as independent platform. Yes, reason dot class file and JVM. So by end of this JVM. Yes, JVM is there. JVM makes the Java program as independent platform. Okay. Now here question doubt is here. Doubt is JVM, is it part of OS? Is it part of Linux space? Is it part of Windows space? Is it built in with operations? No, it's not a part of OS. JVM is not a part of OS here. Okay, then how to get JVM? Yes, the JDK software you have to install it. Once the JDK software installed, so getting JVM. Suppose in my system JDK software, see this JDK software, JDK 8 and 9. So JDK 8 is JDK software installed. JDK software installed. So once the JDK software installed, then getting JVM. So JVM it's a part of JDK software. So JDK should be installed. To run the Java dot class file, first of all you have to install the JDK, then run the dot class file. So once the JDK installed, so generating JVM, getting JVM. So for this here are JDK installation, JVM. Okay, yes, here also JDK installation, JVM. See Linux. On Linux also Linux versions Java C, same Java compiler. Okay, yes, Java. See that it's available. Yes, in my system installs. Yes, in my system Java is available and Eclipse on the complete Java environment setup is there because I'm using for Hadoop applications. See, generally Hadoop application development completely on Linux base. Java application development you can do on Windows base anywhere here on Linux base also, but Hadoop compulsory on Linux only. Okay, yes, now okay, fine. So here now JDK, once JDK installed, so getting JVM automatically. Okay, yes, next one more important point here. Java dot class file is independent platform. Yes, your Java programs are independent platform, but JVM is OS dependent. Java programs are independent of OS. Java program is independent of OS. Java dot class file is independent of OS. But JVM is a OS dependent. So why JVM is a OS dependent? Reason JVM developed in C++. Okay, JVM is a C++ exe file. That's the reason. JVM is a C++ exe file. JVM is a C++ exe file. JVM is exe file. So JVM is not a Java program. JVM developed in C++. If developed in C++, that is exe file. Yes, C++ or C language exe file concept, right? JVM developed in C++. Okay, C++. So it's a C++ exe file. Since it's exe file, it's OS dependent. Okay, see this JVM contains Windows JVM, JVM for Windows base, JVM for Linux base, JVM for Unix base. So different JVMs were developed for different applications. Okay, JVM for Windows base. So this JVM is having knowledge of Windows OS, so then it communicates with Windows library. That's it here. See this JVM, it's exe file. Right? This is exe file. This exe file contains what? See this JVM exe file prepared for Windows OS. That means this JVM exe contains Windows library. Yes, this JVM it's exe file. JVM is exe file. Okay. Still, this JVM exe file contains what Windows library, right? Yeah, this is having Windows library. In this Windows library is there. Okay, with that library, JVM can communicate with Windows OS here. That's it here. So this JVM is having, yes, this JVM is having Windows library, so it's having knowledge of Windows OS. So this JVM prepared for the Windows OS, it's having knowledge of Windows library, so that it can link test.class to Windows library here. Next, this JVM prepared for Linux OS. That means this JVM is having Linux library. So with that library, it can link test.class to Linux library. That's it here. So Windows JVM is having knowledge of Windows library, so that it can link test.class to Windows OS library. Yes, Linux JVM is having knowledge of Linux library. It can link test.class to Linux library here. Similarly, Unix JVM is having knowledge of Unix library. Then it can link with this Unix base. Okay, so you get JVM. So different JVMs for different operations. JVM is not same. JVM is OS dependent. So Windows OS JVM is different. Linux JVM OS different here. Yes, Unix OS JVM different, right? JVM changing from OS to OS. Okay, Sunsoft they have developed different JVMs for different operations. Okay, Sunsoft they have developed different JVMs for different operations. Okay, so Windows JVM. So how to set up Windows JVM? Windows based JDK you have to download it. So JDK changing from OS to OS. Same software you can't use with all the operations. See, this is Windows JDK. See, Windows JDK, Windows 64-bit OS, right? So Windows 64-bit. See, let us check it. JDK software. See, JDK software. One second. JDK software. JDK software. See, JDK softwares. One second. See, JDK software Linux base. They are the JDK products for Linux base. Different Linux. Okay. See, Linux, different Linux. Yeah, this is for Ubuntu Linux base. Next, this is RPM. This is for Red Hat Linux base. The Debian Linux base. So like this also for Red Hat. Next, Mac base. For Mac base, for Mac. JDK for Mac OS, JDK for Mac OS. Okay, JDK for Mac OS. Next, yes, JDK for Windows OS. So JDK for Windows OS, right? Okay, so JDK changes from OS, Linux OS, Mac OS, Windows OS. You have to download different JDKs for different operations. Yes, you guys don't worry, I will provide it. I will provide the JDK software. Okay, so JDK is a OS dependent because of JVM. Because of JVM, JDK is a OS dependent. So different JDK software you have to download for different operations. Okay, so this is independent platform. How Java made us independent platform? Okay, now let us see exe file dot class file. What's the difference between these two? Yes, difference. Yes, explain about exe file, explain about dot class file. Now let us compare these two here. Exe file explained very clearly. Dot class also explained very clearly. Next, how exe file is working, clearly explain. How dot class are working, clearly explain. Now let us compare these two. Let us compare these two. Let us compare these two. Okay. Yes, you understand about exe file, you understand about dot class. Once you compare it here, then easy to remember the topic. So let us compare this. See exe file dot class file. See first point. First point. See exe file contains what binary code. That point already we discussed. Okay, dot class file contains what bytecode. So here exe file on dot class file. See exe file, it's a binary code file. It's a system understandable language. Exe file is a binary code file. It's a binary code file is system understandable language. What is dot class? It's a bytecode file. It's a bytecode file. It's a JVM understandable language. Bytecode is a JVM understandable language. Binary code is a system is a processor understandable language. It's a processor understandable language. Binary code is a processor understandable. Bytecode is JVM understandable. Okay. Yes, these points already be discussed. Okay, next third point. See this. Exe file. It contains program code plus software library plus OS library. That is exe file. What is dot class file? Pure Java program. Dot class purely Java program. Don't have any OS library. It contains bytecode for Java program plus bytecode for OS library only. Sorry, bytecode for Java library. Bytecode for Java program plus bytecode for Java library. Right? Yes. Right, next. See exe file. Exe file prepared on specific OS. Exe file prepared on specific OS is a prepared file. Exe file is a prepared file for specific OS. If exe file prepared on Windows OS here, that library links to exe file, right? Means specific to OS. So exe file is prepared for specific OS here, not for all. But dot class file is not a prepared file. See, dot class is not a prepared file here. Prepared, not prepared for any OS here. So dot class file is not a prepared file. Yes, you don't have any OS library. Okay, right? Yes. See here next step. See OS library statically linking with exe file. OS library statically linking with exe file. Here OS library. See OS library dynamically linking with dot class file at runtime. Depends on OS that link changes. Depends on OS link changes. So dynamically link changing, right? Runtime link changing. Okay, same dot class file linking with Windows OS, sometimes linking with Linux OS, same dot class file with Unix OS, right? At runtime that link changes. Whenever OS changing, link changing automatically. So that's a dynamic linking. Since is a dynamic linking, it's a OS independent. OS independent. Okay. Yes. Even Python also same. In case of Python script also, whenever OS changes, that link changes. Python scripting also independent of platform. Python scripting also independent of platform. In Python scripting also, yes, at the every time of changing OS, that link changes. Python also dynamical linking, not static linking. Python scripting also dynamical linking. Okay, so OS library dynamical linking with dot class file at runtime. Okay, right? Yes, next point. See, exe file is already prepared one before running on OS. So exe file is already prepared one before moving on to OS. But dot class file, see, dot class file is not a prepared file. After moving on to OS, JVM prepares as per the current OS. Okay, so dot class file after moving is practically assured, right? Yes, after moving on to OS here, after moving on to OS, so JVM taking dot class file links with OS library means preparing at runtime. This is runtime preparation. Okay, dot class file is not a prepared file, it's not a prepared one. After moving on to OS, JVM prepares as per current OS. That's it. Okay, yes, next. Next here, see, next difference, exe file executes faster than dot class file. Reason here, exe file already linked. Exe file is already linked with OS library, directly executes. Linking is not necessary. But when come to dot class file here, dot class file preparing at runtime. Since dot class file preparing at runtime, it executes slowly than exe file. See, dot class file after moving on to OS, okay, linking and running. So linking it will take some time here. So for linking at runtime linking here, runtime linking. So runtime linking it will take some time. Okay. Yes. How that runtime linking happening we'll discuss in JVM. JVM we have separate class on JVM. Okay. So JVM topic is there. So in that topic I'll explain very clearly how that Java bytecode is linking to yes OS library. How JVM linking dot class to OS library. That concept also I'll explain very clearly. The JVM internals also I'll explain. Okay. So here since dot class file prepared at runtime here, it executes slowly than exe file. So exe file is perform better than the dot class file. Okay, right? Yes. Next here, see, to run exe file. For example here, for example, 1 second. Suppose, so this is Linux 1, Linux 2, Linux 3, Linux, totally 4 Linux computers are there. In my system, there are 4 Linux systems. 4 Linux. Yes, first one is running, started. Second one, yes, next we should start it. Start it. No, Linux is running. Linux is running here. Okay. Now in this Linux here, see. So this exe file prepared, right? For this purpose, in this Linux, C software install, C GCC compile is there already. The C language compile is there. Means C software installed. Just in this Linux page, on this Linux page, C software installed. So program developed here and create one exe file. So project exe file created. Now this project exe file can move to same Linux page. Okay, another machine, but same Linux page. Another machine, same Linux. Yes, it works directly working here. Yes, on second Linux machine. Yes, here on second Linux machine, again installing C software not necessary. In first machine, C software installed and developed. So we got the exe file. On first machine, we got the exe file. This project exe file, you can move to second machine with same Linux base. Same Linux base here, and you can run directly. On second machine, C software not necessary. Once exe file is prepared, okay, it's already prepared file. Already prepared. Again, preparation not necessary, directly running. It's a prepared file, directly running here. Same Linux base. Suppose Linux flavor change, it won't work. And Ubuntu Linux is prepared, right? Yes, same exe file placed on CentOS or Red Hat, it won't work. Same Linux base, it work here. It works because already prepared. Prepared for Ubuntu Linux base, it is running on Ubuntu base. It is running on Ubuntu base, right? So without installing C software, okay, to run exe file on same Linux base here, same flavor. Yes, C software not necessary to install. C software is not necessary. Okay, right? Suppose Java program. Come to Java here. Suppose dot class file. Dot class file prepared in Windows base, right? Now this dot class file. See, dot class file on Windows base prepared. So dot class file prepared in Windows base here. So moving on to Windows base here, the dot class file links with Windows base library. So you can JVM required. Same dot class file running on Linux base. To run on Linux base, JVM should be required. Without JVM cannot run. So how can you get JVM? JDK should be installed. That means to run the dot class file. To run the suppose dot class file prepared in Windows base here. Even prepared in Windows base to run on other Windows system. To run on other machine, same with Windows base. Same with Windows base here. Even same Windows, there are also JDK required. JDK you have to install Java software. To install the dot class file, Java software should be installed. So without Java software, yes, dot class file won't work because JVM required, environment required here. Okay, to run the C program exe file, C environment is not necessary. To run the C program exe file, C environment is not necessary. Okay, to run the Java dot class file, Java environment required means JVM required. Okay, Java library required and everything required here. Otherwise, it won't work. Okay, same point mentioned here. See this here. Yes, to run the exe file, that application software, to run the exe file, that application software means C application software or C++ application. These application software is not necessary here. To run exe file, application software not required to install. Okay, next to run dot class file, JDK. To run dot class file, JDK should be installed on OS here. To run the dot class file, JDK required, otherwise cannot here. Otherwise cannot. So this is difference between exe file dot class file. Is it clear? Yes, guys. How? What is exe file? What is dot class file? How is Java made as independent platform? Yes. Is it clear? All the points. Today class. No doubt. Wonderful class today class. Okay. I think every point is clear. Yes, guys. What's happened? No response. You understanding? Hello. You understanding? See, 1 second. Yeah, this type of explanation, yes, no websites will explain like this. No trainer will explain. Okay. Yes, this type of explanation for this purpose, lot of knowledge required. Like Linux based knowledge required. Next, embedded C knowledge required. Java knowledge required here. OS internals knowledge required here. Yes, all the concepts required. Otherwise, cannot explain. I have multiple experience. Linux based very good experience. Next, embedded C very good experience. Java very good because of all that experience. By combining all that experience, only I am able to explain this. I am sure no trainer will explain like this. because the trainers simply learning Java and explaining, that's it here. Even they don't have real-time experiences. Okay, not only having knowledge, I have the real-time experience. Okay, you will practically showed. See, the TXE file content parts. Yes, file, the TXE file projects. Okay, yes, Linux library linked with the exe files. Practically showed, everything practically showed. Everything practically showed. Okay, yes, no trainer will explain practically about independent platform. See, 1 second. Now here, come to this point here. See, what I told you, yes, at the beginning, 2 days before, 2 days ago. So what I told, to understand independent platform portability, there are some prerequisites required. But directly can't understand independent platform portability. I told you. Reason. See, last 2 classes. Now you understand why I told you like that. Last 2 classes, concept is a prerequisite to understand today class. Yes, do you agree with that? Last 2 classes. Last 2 classes is a prerequisite to understand today topic. Otherwise, you can't understand. Generally, most of the trainers simply what are the Java features means directly just they will explain about definitions. Independent of platform means so dot class file in Java everything is dot class file dot class prepare and yes one operation running on anywhere. Yes, prepare dot class preparing on anyways and running anywhere. That is independent of platform. Simply they will explain like this. Okay. Yes, how made a Java independent of platform? JVM is responsible. Only 2 points. Okay, dot class file running on one voice and dot class for preparing on one voice and running on every voice. Next, beginning of JVM. Only these 2 points they will expand here and they will go to next topic, next up. That's it. That is actually what trainers will do. But that is not my way. Okay, every point I'll go very in depth. I'll take my own time. Okay, I'm not a commercial. I don't need this training amount. I have my separate income is there. Okay, I have very good property. Okay, properties and everything here. So this is teaching is my passion. Okay, I think you observed my way of teaching. Okay, so I think you observed my way of teaching. My way of teaching tells how much I passionate towards teaching. Yes, a trainer way of explanation tells that the trainer is passionate towards teaching or is teaching for money. That the way of teaching tells. Then even way of teaching tells he is having experience or not. Experience or not. Okay. Simply here my subject is heartfully I will explain. Okay. I'll explain heartfully here. Explaining very clearly subject here. The amount may be getting or nothing. That is secondary. Just simply explain very clearly topic here. Okay. Every point, each and every point repeatedly, clearly. So without any confusion, I'll be explaining clearly here. Not only here, everywhere. Okay. Yes, even Java program. When you're writing Java programming, behind of Java program, JVM working. Behind of JVM, C++ code is working. That C++ code also I'll explain. Okay, just you ask your friends, any who completed Java in my batches, just ask them behind our JVM, what was happening here. So what's happening here? How C++ program is working. That memory maps, including memory maps, every program I'll be explaining here. That is my way of explanation. Okay. Sure, I'm sure no trainer just will match to this type of explanation. Okay, no one. I'm sure this is. Okay. Even websites also. See, just simply simple one example here. Here just you search for what's the difference between .exe file .class file. Search in Google, search for exe file .class file. Okay, you will get only 2 points. Exe file is OS dependent, .class file is OS independent. Okay, exe file is OS specific, .class file is independent of OS. Only 2-3 points you will get, but you can't see this much of points. Okay, see my experience, my standards are more than the Google. Even Google also can't reach my experience. My experience different. 20 years of experience on multiple skills. So my experience Definitely 100% more than the Google. Even Google also will not give. Google nothing but different software developers share their experience. Okay. So in Google also will not give that much of information. Yes, I'll give that much of information. Okay, not only here, even going forward, you'll see in every program, every topic, yes, more than the Google. Even you searching in Google, you can't get that kind of information and that kind of yes programming skills. Okay, so that is my classes. I'll maintain some standards and dedication. So dedicatedly taking classes and maintaining standards. Okay, there are certain standards I will maintain that. Okay, that's the reason I got this success within short time. Yes, training classes. Okay, see just to last two almost 1.5 year completed these online training classes. 1.5 year, 1,000 members training completed already. More than 1,000 members training complete. Java, 1,000 members students I have completed just 1.5 year online classes. So every batch minimum 30 to 40 members. Yes, your batch also will be 30 to 40 members definitely. 11:45 batch started. That batch is merging with your batch. 11:45 in that already 15 members are there. 15 plus your batch, I think 10 to 12 members, 25 members, 25 to 30. That batch also merging into this batch. Parallelly started. Parallel with you only just 2 days. 2 days difference between you and them. Okay, 2 days between you and them. Okay. These both batches will be 30 minutes, no doubt. Okay. Yes, yes. So that's all for about independent platform. So next topic is installing Java. Okay. Tomorrow, Java installation. See, Monday to Saturday classes. No Saturday holiday. Monday to Saturday. Only Sunday holiday. Tomorrow, Java installation. How to install Java. Next, how to install Eclipse. How to develop application in Eclipse. So tomorrow, I'll be going for installations. Okay. I'll finish that installations. Sunday, we'll get the gap. So that gap you can utilize for installations. Sunday gap. With Java installation, Eclipse setup, you can set in your system. You can set up in your system. Okay, for this well-prepared document is available and recorded video. I'll share all this with the help of this is set up. Still, if you facing issue, in installation, you can contact me. Okay, yes, you contact me. Just you can ping me. I'll respond. Then I will connect to your computer. I'll make it set up. Don't worry. For everything, I'm here. For any kind of doubts, any issues facing, just ping me. Just within 1 second, I'll respond you like a Google. I have that name in students. Immediately I'll respond. Okay. Yeah. Yeah, that's all for today. Yes, we'll continue tomorrow. Tomorrow for installations. Tomorrow install Java installations. Okay. Yes. I think already software shared to some students. Java software and Java documents already shared to some students. Okay. Yes. That's here. That's all. So thank you guys. Yes. Any doubts? Yes, guys. Any doubts? Yes. If no doubts, let us wind up session. Thank you guys. See you tomorrow.